going to solve a problem in geometry. So I saw this problem on a YouTube channel named Mind Your Decisions. So he came up with an elegant solution to this problem, and I just want to share another solution to the problem. So this is the problem. So we have here a square, and its side measures x here. Then we have here a line segment from this point to this point here, measures 12, and another line segment here, and these two here are perpendicular, so this is 3. Then another line segment here from this point to this point, and these two line segments here are also perpendicular. So the question here is, what is the value of x given the following measures of line segments? If you want to solve the problem, you can pause the video and watch it later for the solution. So for the solution, I will just extend this line segment here, measures 3, up to this vertex here. So in here I have formed two right triangles. This one here and this one here. So this one is 3, this one is 12, and I will just let this line segment here from this point to this point as y. So this is a square, meaning this line segment here is also x. Now for the solution, I will just use the Pythagorean Theorem. Now x here, this is just a hypotenuse, and also here, the x here is also the hypotenuse. So for the solution, we're going to have this one as triangle number 1, and this is triangle number 2. Now for triangle number 1, using the Pythagorean Theorem, you can have x squared. This is the hypotenuse, equals 12 squared. This is the leg here, and another leg here. This one measures y, plus y squared. This is for triangle number 1. Then x squared is equal to 12 squared is 144. So 144 plus y squared. Then for triangle number 2, this is x squared equals 9 squared plus this line segment here. This is 3, then this is y, so we're going to have 3 plus y squared. Then 9 squared is 81. Then 3 plus y squared, and have that one as 9 plus 3 times y is 3y times 2, 6y plus y squared. Then simplifying, we can have x squared equals 81 plus 9 is 90. Then plus 6y plus y squared. 9 here, this is x squared equals 144 plus y squared, and this is x squared equals 90 plus 6y plus y squared. So we can say that the right side of the two equations are equal because they are just the same, x squared. So we can have 144 plus y squared equals 90 plus 6y plus y squared. Then combining like terms here, we can have y squared transposed to the right side, and we can have 90 to the left side. So we can have 144 minus 90 equals y squared plus 6y, then minus y squared. Then y squared minus y squared is 0. So you can have 6y. Then 144 minus 90, this is equivalent to 54. Then dividing both sides by 6. So 54 divided by 6 is 9. Then 6y divided by 6 is y. So we can have the value of y here equals 9. So since y is equal to 9 here, we can now find the value of x here. So we have here in equation 1, x squared equals 144 plus y squared. So using that one, 144 plus y squared. We can now find the value of x here. So x squared equals 144 plus y equals 9, 9 squared. So x squared equals 144 plus 9 squared is 81. Then x squared here is equal to 144 plus 81, that is 225. Then extracting the square roots, x here is equal to 50.